So, I'm Nik Rykov, and I'm the lead maintainer of the RareWeave. And the RareWeave is the ultimate content market built on the Arweave. Now, who has heard about the RareWeave before? Raise up your hands. Yeah, I see quite some hands. So, I might disappoint you, but RareWeave is not what you're thinking. It's not the NFT marketplace. It's the NFT framework optimized for the new phase of the tokenized and decentralized web, also called Web3. So, what are the problems with the current phase of the Web3? So, the opinion like solutions for the next phase. And the problems are right here. So, first problem we have is the scalability of interaction storage. Then we have scalability of interaction execution, low utility of NFTs and smart contracts, and the fragmentation of the ecosystems. And these problems, they come on top of each other. So without the solving the scalability of interaction storage, you can't solve the scalability of interaction execution. And without these two base layers, without the fundamentals, you can't really solve the low utility, because you can't add some cool features if it just falls apart. But thankfully, there is one solution to the scalability of interaction storage. And this is the BlockWeave, the technology used behind the Arweave. Now, I'm not going to explain how it solves the scalability of interaction storage, because probably a lot of you already know, how it solves, and maybe some other speakers will tell how can it scale the storage problem. But now the point is that we can move on to scalability of interaction execution, and this is the fun part, because no ecosystem solved it in proper way. So we have this dilemma. Your contracts are either complex or non-scalable. And we kind of see this problem, but we choose the complexity side. So let's first figure out how the simple solution works. Simple solution being the short state that every blockchain uses, like Ethereum, Solana, Tezos, and all other general purpose smart contract chains. And how it works is that when your contract wants to call some other contract, for example, token contract, to transfer it, like custody, then this contract adds itself as a dependency to the callable contract. And on low scale, it might seem quite nice, because why not add it's like a massive dependency? But you might already guess from where problems come. And problems come with the popularity. So as soon as your contract gets more attention than 5 people using it, then you have the whole army of the smart contracts trying to get into your contract's dependency. And this is what we call in JavaScript the dependency hell. And it exists in literally every ecosystem right now. So when we want to fetch the state of my simple contract, for example, naming system or something like that, then you also have to fetch the payment token state. And while fetching the payment token state, you also fetch the AMM, where this token was once swept. Then they watch fetch some meme coin state, some random NFTs, and all this ecosystem. So in that, you result to fetching all of the blockchain interactions and executing them just to get your simple and small contract state. And this is not really a scalable solution, which kind of explains why Ethereum has such a high fees and why in general blockchains have a pretty big fix. Because each interaction you add to it also loads whole ecosystem with it. So we can't really solve it in a, we can just increase the block size or something like that, because it will still grow and pollute the ecosystem. So what is the solution to this problem? That is isolation of the contracts. So how do we get rid of the dependency hell is we just don't let our contracts communicate, right? And yeah, this solves solution, and this is how SmartWeave worked for a long time. So you have only your smart contract, which is scalable because users fetch only interactions from your smart contract. It's pretty cheap to write interaction to your smart contract because it doesn't load the ecosystem, and your smart contract pretty much gains all the scalability advantages. But what is the downside of this approach? And you might already guess, because isolation isolates you from the ecosystem, right? So you can't use, for example, Ethereum in your smart contracts, because again, your smart contracts can't custody it. But you might read it, Ethereum state. But don't custody it, because you're basically adding yourself as a dependency to Ethereum if you look some. So if you think like this, can you add yourself as a dependency to Bitcoin, for example? No, like it's not the way. So so the solution to this problem, there are multiple solutions. The first solution is inter-contract bridges or oracles, which execute one contract and deliver its state to another contract. This solution has some pros, but also cons. The main advantage of this approach is generalization. So you don't need to do a lot of work from transition from the shared state to the bridges, because it's generalizable and you can pretty much just write to another contract. Yeah. Also, it's simple to implement for the contract developers and the ecosystem, and it's fork intolerant. So if you, for example, make a swap, then you're sure that you made the swap and you got the tokens back. But of course, the solution might be not best. Firstly, because of the security of this approach. And you probably heard a lot about recent breach hacks. This happens almost to every breach, and they get leaked millions because it's a honeypot, and there exists the honeypot crash. So also it's forced proof of stake or proof of authority. So you can really use more decentralized algorithms in these breaches, like proof of work or Spora that RareWeave uses, native Spora. So you're pretty much locked in this proof of stake cage. And some decentralization pros are lost. Then the fork intolerance is also a disadvantage, because if your breach tolerates forks, and pretty much on fork your breach gets hacked. So you don't have the tokens anymore. Then there is a lack of incentive to execute the contracts, which may be solved by adding additional fees, but it's already solution to the solution. And it's the who watches the watchman problem. Also, the scalability problem doesn't really go away, because just it moves to these watchers, to this to deliver, to Oracle, to bridge. So there are really better approaches, like, for example, hash time locked contracts. And I know Warp contracts did do some development in this area with their teleport protocol, which allows for interchain buys from Ethereum, for example, to SmartWeave. Here is outlined how the hash-enveloped contract work. I'll not explain it right now in detail. You can Google it, but I'll try to explain in simple words. So basically, you have the page blocked with hash. Who is familiar with hashes? Raise up. Yeah, see, quite a lot of people are familiar with hashes. So you lock your first target in this page with hash, and you keep the secret, so the source which would pipe through hash, like to yourself. Then you send this hash to another person who tries to communicate somehow with you, and he locks his target as well, like for example coins or something like that, like NFT. Then you just reveal the secret, and you both get your target, so you complete swap. It's as simple as that. So there is also some like comparison table. You know, main pro of this approach is the scalability of this approach. So you don't really need the shared state or something like that to do it, and it's really scalable. Also, it's really decentralized because it's kind of peer-to-peer, because you swap directly with person that you need, like without some custodial. Also, it's a secure approach because of decentralization. Well, everything that's decentralized properly is secure. And it's fork intolerant. I did explain the cons and pros of the fork intolerance in the previous section. From the cons of it, it's the lack of generalization. So, of course, you can complete the swap with the HTLC approach, but you can't really complete a lot of other things. Like, for example, passing some values from one contract to another, because your scope of what you can apply is basically just to people locking something. Then there is another con, and it is the interactivity of the HTLC protocol. So both people, if you look at this scheme, both people need to communicate, and it is really a problem. Like, for example, you list something on some marketplace, then you disable your computer, go away, go to ETHWarsaw. Thanks everybody for coming. And yeah, you like buyer can't buy because you're not communicating with him. So RareWeave took the Nik approach. We did look at the real world. How does it happen in the real world? In the real world, how it happens is that I give you something and you give me something. Yeah? So no looking like we don't give it, for example, to some other person to hold and then give it to us, how it happens like in visual contracts. Like here is the construction of visual contracts. So seller transfers basically the asset to some marketplace, some custody. Then this custody also like lists it. So buyer can also transfer his another asset to this custody. Then this custody swaps it by places and reissues second asset to the seller and first asset to the buyer with the buy function. So the problems with this, with basically traditional approach, are the requirement for contract being able to custody tokens. It's a main disadvantage. And why is it disadvantage? Because you can't really custody tokens with that scalable approach. So your contract is isolated. Yeah. This also comes, with loading of needed interactions due to first, disadvantage and the global state problem. So how does it work on RareWeave? On RareWeave, we just identify in the smart contract itself that it's being for sale. The NFT is being for sale. And so we don't have to share the state with the marketplace smart contract. Then some buyer finds our NFT and transfers tokens directly to us, not to some custody or something like that, directly to us. Then the NFT contract reads our basically transaction and just assigns ownership of itself. Also, as a bonus, we get the native cross-chain payments. So this transfer that's happening, buyer and seller, it can happen on any chain. So on Solana, on Bitcoin, on EVM chains, on non-EVM chains, on any chain basically, except for maybe privacy chains. So we get this ease of the integrating of the foreign chains. It has more pros and cons. So it's scalable, decentralized. It inherits security from chains it relies on. It's fork tolerant. So if fork happens and the buyer gets refunded, then the seller gets refunded as well. So he gets his NFT back. It's non-interactive, so you can list your NFT, go away, and it will still be able to sell itself. It's pretty simple to implement if you look at scheme. And of course, easy interchangeability. The goal of this approach might be the lack of generalization ability, but you can really figure out something with it. The point is to get into that person-to-person approach. Also, you inherit security. Inherited security is both pro and con because you have to rely on the security of the underlying chains. And it's fork tolerant, so you might be not sure that your stuff happened. So it's also wrong. So thanks everybody for watching, seeing this presentation. And the point of this presentation is not to give you the full cover of the problem. So if you want to know more about this problem and how to solve it, alternative approaches, then contact me on Session, X, Discord, or Telegram, and I will provide you with more comprehensive talk about it. Also, just come to me somewhere there, and I will talk about it for you for as long as you want. Because, passing to the next.